I've not been reading Len's notes on what the focus was today, so I'll be skipping through a lot of my slides because I was focusing on a different group. I've been talking to a lot of architects in the last two months or so. So I'll be skipping as we go and just talk about 3 key projects that I've been involved with recently. I'll skip through a lot of these general things that you know, because I had picked it up for a different type of audience. I haven't been reading emails recently, been struggling a bit. So just listening to the previous speakers gave me a better idea of what the day was about. So building on what Phil said, we've been doing some work together with Phil. I'll come to the large project I led till 2020, which is the CRC, Cooperative Research Center for Low Carbon Living, which was a $104 million large project, many projects and within that, and I'll talk briefly about what we tried to achieve there. But one of those was a post-CRC project, which finished and got published beginning of this year on net zero again, our net zero focus work. Looking at a whole of building, whole of life thinking. There is a lot of focus between, I deal with engineering and society groups, and I'm on the National Institute of Architects sustainability task force, looking at how they need to change behavior and focus. And they are beginning to think quite a lot about whole of building, whole of life. We thought we were trying to push it from the research side, but there is a huge appetite on the designer side to start looking at. But they don't find that they don't have credible tools and consistent data sets and things to calculate on. So we are trying to put some of those together. Obviously, the embedded carbon, Phil is one of the big time experts in the country and talks about that. But within that, the operational and circular economy approaches, which is beyond life. How can you design for deconstruction and all of those, so that you can also link that with decarbonization, with reuse of materials and things being feasible, for example. So we took a approach in determining, again, not building on Phil's work, but another bit of work we did, looking at top-down and bottom-up approaches to net zero at building scale. The top-down being as the grid greens in Australia. I think we have a quite a positive thing. 10 years ago, there was only about 8 or 9% of electricity in the grid was renewables. This year, it's about 35 to 40%. And by 2030, it should be about 75 to 80% renewables in the grid. For a country that's world's largest exporter of coal, I think it's quite remarkable the way things are going. So if the grid is greening at a pace that it is, how can we attribute that to building energy usage? Because we are beginning to use a lot of green energy, the stuff you buy to heat, cool, and all of that. The calculations are changing, in other words, and how do we adjust to that? The bottom up is all of things we do as designers, architects, engineers, in terms of minimizing demand, for example, through good design, and then looking at approaches like a whole range of options that you can choose from, efficient HVAC systems and all the equipment, lighting and all of that we choose to make buildings more comfortable and workable and all of that for better IEQ and all of those things. So energy efficiency more broadly, how can we bring that down to a lowest possible target, for example, so that we have less of renewables required to offset and might take it to zero. So threefold approach. We were looking at energy efficiency through good design and what architects know and don't know and what they can do to deliver. Then integration on site, photovoltaics, for example. So residential level, we have about 3.5 million photovoltaic panels on households, not panels, 3.5 million households with photovoltaics integrated in buildings. So that's bringing the demand down, for example, and photovoltaics has become really good payback in Australia at the moment. $3,500 gives you 6.5 kilowatt of PV on the roof. And for a 3 to 4 family house, you are getting very close to generating all the energy you need, for example. So things are changing, is what I'm basically picking up there. And then we go to, if you still cannot do net zero today, you can go to offsite sourcing of renewables in your portfolio. Within the sourcing, for example, this campus that we on, it's done its numbers and it can. The university has a solar farm out near Victorian border, photovoltaics, and they are able to generate as much electricity as the total demand over a 24-hour period is on campus here. So even though there is no generation at night time, the base load is about 3 megawatts or so, but we're trying to offset using renewables that we contributed to in terms of a solar farm as a campus. So some of those things are beginning to have a dent in the national electricity grid, as well as the demand side in terms of how we design and use our buildings. So we did a lot of assessments of how we can achieve net zero buildings in Australia for different climates, because we spread from really south in Tasmania to Darwin, for example, and broad range of heating and cooling dominated climates. So we found that by 2021 we had all the benchmarks done, which we largely do. 2025, all the necessary standards and things are in place for measurement and tools and things. That by 2030, for all new buildings, we should be able to achieve net zero carbon. But at the same time, with all the push from the engineers, architects, and politicians. Yesterday, we had a call from an independent member, a Teal member who is the federal parliament, trying to put in a private member's bill for addressing net zero carbon in different ways. And she was trying to get evidence on some of the things she's trying to achieve by 2030. So in the next sitting of Parliament, she will put up a bill, for example, that will try and legislate and lock in higher levels, even higher levels through the building code of Australia, which is one big lever, but at other levels, incentivizing a whole bunch of other technologies and things. So there is a serious commitment in that sense. And by 2030, a lot of the embedded carbon reductions will have taken place at the same time, which is consistent with what Phil's work was trying to do. Existing buildings is the big one. Buildings that are already there, and we find that to a large extent through refurbishments, it's very difficult to have retrospective legislation to get them to change things. But the government is looking, and this private members bill is looking at again trying to provide free insulation and a whole bunch of other advice on existing buildings, including incentives for refurbishing for sustainability. So people will get access to funds to be able to do that. So the work we do links very directly with government. We work very directly with government and industry peak bodies that together push for some of these ambitions. And by 2035, we think a lot of the embedded carbon issues, not all, but will through new material substitution and all that, that's on the horizon. We should be able to, whether we will be in that position, we don't know. But by 2040, we aim that, and our research shows that we can achieve net zero ahead of 2050. And in other words, large part of the total building assets can be driven towards net zero. So this sort of work that Phil and Land and others are involved with is trying to provide governments with direct evidence in terms of what is possible, so they can frame their legislation in that way. Another project we are embarking on at the moment, Will and Land, we're trying to look beyond just decarbonization work and trying to see where this whole business of circularity, trying to design, get architects more in tune with designing for not just the life of the building, but thinking of deconstruction, reuse at the early stages, and looking at resilience, because we are beginning through climate change in particular to get a whole bunch of issues in terms of big floods and big fires and a lot of urban heat issues that's being talked about and all of that. So trying to see to what extent through good design and planning we can deal with these, working with councils and in particular Institute of Architects and so forth. So at the moment, only about 7 or 8% of materials, what you call our designs are done with that view to reuse and all of that, but there's a long way to go. I'll skip through some of those. Resilience, obviously, there's big need, and this particular town was designed with a 1,000-year flood next to a river, and it hadn't flooded for about a few hundred years, but it did, and now they're moving the town, for example. So the cost of some of those things are really huge, as we know, and globally, the cost of dealing with the problems afterwards is way bigger than the preventive work. You'll hear a lot about the urban heat issues that's being done, but at the same time, building resilience through power supply. We have done in my CRC a lot of work looking at resilience from the point of view of decentralized generation, using renewables in urban areas and so forth, so that there is not only a high level of reliance in our grid, for sure, but the whole idea behind this project that we did in my CRC was to look at a local community, a precinct level development, and to what extent we can generate electricity for individual households, storage, and then at a community level, about 100 households, so they can buy off each other. They can use their own or buy off each other, and then as a last option, buy from the grid. So that led to a development of an app, for example, which is blockchain sort of linked, and it does peer-to-peer trading, as they say. It allows you to trade off each other's storage and then make grid purchase the last option, and thereby giving higher levels of resilience. And that project, that particular app, for example, has been developed to a point it's in use in about 5 countries now. At precinct level development, they're trying to use it to make sure they can get a high level of renewable energy into the system. I talked about this already. So generating solar at the solar farm and clipping off the daytime peak with purchase from the grid in the evenings on this campus. And that's the building on the right hand side where we are housed. On the other side which you know, a typical 5-star house with a lot of on-site generation and experimentation. Other work we are doing is looking at this whole notion of doing less harm and more good type thinking. So more regenerative thinking or positive development, as they say. This comes from Institute of Architects people. The architects trying to go beyond what's being talked about in codes and so forth. And they're asking us to look at how we can move more quickly towards a nature positive solution sets as opposed to just reducing the harm we are doing by energy efficiency and all of that. So it's more ambitious in that sense. And there are buildings around the place that are trying to achieve that. A lot of work being done in Singapore and so forth. I'll skip. I'll just finish by 2 big projects that I'm working on. This one is just finished. This is our team that were part of this CRC for low carbon living that I ran, which finished in 2020. Some of the projects are still going, and huge ambitions there. We had ambitions of reducing emissions by 10 megatons through the project work we do and adoption of technologies and things. We trained in excess of 100 PhD scholarship students through the center, and a whole bunch of policies which are now, evidence for policy which are now actual government policies. And we actually started the work on trajectory for building code, which is the main lever. So we did the base work, the technical and business case for change to building code that is much more net zero carbon focused, which is now beginning to happen. Phil mentioned the National Construction Code, which is trying to trend towards net zero by 2030, 2040 or so. And we started that project in the center. So a whole bunch of work was done, new technologies in the market, PVT systems and geopolymer concrete, new strands of these we developed that are already being used on big projects. We ran a decision-making tool, evidence creation tool for the New South Wales government for 5 years that provided, when government wants to tackle a particular policy, they ask us to look at the evidence that supports that case, and we provide it, and then they take it to the process in the parliament to regulations. Whole bunch of regulations came as a result of this particular initiative over a 5-year period. Just to finish up, what I'm doing now, I'm running a New South Wales government's decarbonisation innovation hub, and it is trying to support. There's 9 universities are members in New South Wales alone, and a whole bunch, about 80 or so industry partners, and it is going to be pretty large. It's a 9-year program. More than 100 million Australian dollars overall. It's trying to capture what we call TRL3, Technology Readiness Level 3, which is past proof of concept for green technologies, and trying to navigate those out to market in Australia. Australia has a very bad record of taking its own inventions and ideas to market in Australia. IP disappears, and next thing we are buying products based on that IP back in Australia. So the government has set this up so that we try and have local manufacture as much as possible of technologies and ideas by funding it. But the reason also, there are a lot of failures in the education system or research system, ecosystem in Australia. We don't have, academics and researchers who take products to proof of concept. Beyond that, the funding gets very different. Early stages, Australian Research Council funding and similar is easier to deal with for researchers because they are familiar with that. After TRL3, it is venture capital, it's sharp funding, it is philanthropy, it's endowment, and all those funds that they helps you navigate a product from early stage to mid stage, so that industry can have a clear line of sight to a product and a market. Then industry starts investing in that. So we're trying to take researchers' outputs through a journey of this difficult period with venture capital and all of that, and trying to then get a clear line of sight to an actual marketable product, and then industry invests, and we take it from there. The three areas, they're not buildings related at all at the moment. It is power fuels, like aviation fuels and hydrogen, for example. There's a whole bunch of research happening in that area. There is energy systems and electrification. So electrification looks at the grid intelligence, so that all these intermittent inputs like photovoltaics everywhere in the city and around the country, putting electrons into the grid, how can the level of intelligence in the grid be there to make sure it doesn't fail and fall over. So building that. So John Fletcher here is running that. And also regional. We have a lot of diesel substitution work and a whole bunch of carbon reduction potential in regional areas, country areas. We're trying to build that up into technologies that can actually work. So the fourth network on built environment, infrastructure, and mobility, transport. We are planning at the moment to have a start by about middle of next year, and that will bring a whole bunch of new embedded carbon, low embedded carbon materials, and new technologies that enable higher levels of efficiency and so forth. All decarbonization focused and all past proof of concept. There's a lot of work that gets shelved after a certain stage in research development process, because a lot of researchers find it easier to get the next grant, publish your 5 papers, and get your citations up and get promoted. But they leave the product, and the pathway to market is much less clearer. So they drop the projects, and we are trying to pick that up and see what the potential is. So that's the sort of work, pretty varied these days. I'm much more running projects at a large group level, as opposed to my own research has suffered, but that's the name of the game. Thank you.